Aviation Rocket Center. My name is Joseph Vick, and I direct our museum education programming here at the center. I wanted to welcome you all here for our Pass the Torch this evening. So let's get started. I'm going to introduce our AIAA speaker. So we have Major Alex Yela is an active duty Army officer serving as a program manager at the U.S. Army Space and Missile Defense Command Technical Center. He has been a member of AIAA since 2008. He served as the vice chair of the AIAA Greater Huntsville section in the year of 2017 and 2018, and is currently serving as the chair of the AIAA Greater Huntsville section. And he is going to come up now and introduce our speaker, JPL.
Thank you, Joseph. Good afternoon, ladies and gentlemen. As the chair of the American Institute of Aeronautics and Astronautics Greater Huntsville section, I'd be amiss if I did not let you know about some of the great things our team is doing here before I introduce our distinguished lecturer. The Greater Huntsville section is putting together the Next Gen Technical Symposium, October 24th to 25th through 26th at the Spring Hill Suites. This symposium is designed to give young professionals and junior professionals the opportunity to present their work. This will be the third such young professional symposium that the Greater Huntsville section is putting on. This year, our featured keynote speakers include Mr. Robert Lightfoot, the president of ELSING, and the former NASA administrator. If you'd like to find out more or would like to be a sponsor, please visit the event website, www.aiaaanextgen.org. We also have multiple upcoming fundraising events, monthly lectures, and volunteer opportunities. Right now, we are working on putting together Arduino and Rocketry Level 1 programs and classes. We're definitely interested in having volunteers for that. Please visit aiaa.org to become a member, or check out our section's Facebook page or website at engage.aiaa.org/Greater Huntsville. Also, if you are a UAH student taking MA 200, please see Katie to make sure you get credit for attending this lecture. Mr. Todd Barber is joining us today thanks to Dr. Naveen Vicha, our immediate past chair's hard work. He put a lot of time and effort into organizing and coordinating this event to get Mr. Barber out here from NASA JPL in Pasadena, California. Todd is a JPL Senior Propulsion Engineer who worked as the lead propulsion engineer on the Cassini mission to Saturn. He has previous interplanetary experience from working on the Mars exploration rover, the Deep Impact mission, which impacted Comet Temple 1 on Independence Day 2005 at 3,000 miles an hour. Test?
Yeah.
All right.
Yeah. Thank you.
The Mars Science Laboratory and the Curiosity rover. Mr. Barber also worked for 7 years to get the Galileo spacecraft into orbit around Jupiter in December 1995. Mr. Barber has a Master's of Science and Bachelor's of Science. All right, there we go. Mr. Barber has a Master's of Science and Bachelor's of Science in Aerospace Engineering from MIT. Music. From MIT. Today, Todd Barber will share us with his experience on the Cassini mission to Saturn and give us a detailed overview of the mission. Please join me in welcoming Mr. Todd Barber.
Thanks a lot. Can you hear me in the back okay with the cordless headset mic? We're good? Wonderful. Okay, I am astonished at the size here. I mean, I know this is Rocket City, USA, but this turnout is fantastic. And I love to see all our space campers here. Anybody in 8th grade? Okay, that's a good chunk of this room. That's a very interesting time in your life, because when I was in 8th grade, I figured it all out. And no one figures it out that early. I realize how lucky I am. But what happened was, aren't we in the National Geographic Theater right now? I can't believe the serendipity. because when I was in 8th grade, I was a nerdy kid in Wichita, Kansas growing up. I visited my grandparents in western Kansas on their wheat farm every summer. And I had this weird explorer gene and wanted to go see all of the country and all of planet Earth, every corner of planet Earth. There are no corners. I'm not a flat earther. I want to make that absolutely clear. My grandparents loved to travel. It skipped a generation. My parents didn't like that so much at all. So, and they felt bad. They're like, you know, we'd love to take you somewhere and go exploring. We can't. We have to farm wheat. But I have a magazine that will take you places. So for the first time, they showed me National Geographic magazine. They were subscribers. And I read 5 years of back issues, 60 issues cover to cover over 2 weeks. And indeed, I learned so much about planet Earth. It took me to all the nooks and crannies of this beautiful home planet. But because of my advanced age, this was about 1980, 1981, right when the Voyager spacecraft were flying by Jupiter and Saturn. And there were feature cover articles in National Geographic showing pictures of Jupiter and Saturn. There are dozens of moons. And as soon as I saw those pictures in 8th grade, I said, I don't know anything about this JPL, what it's like to live in California, but that's where I want to work. That's what I want to do with my career and my life. And JPL is my first job. I've been there 28 years. I can't believe my luck. And in fact, then, Voyager took advantage of this cosmically improbable alignment of Jupiter, Saturn, Uranus, and Neptune, the 4 gas giant planets, on the same side of the sun. And it only happens every 176 years. And this happened in 1977. And someone realized this in the early 70s, so they went to President Nixon's office. They said, now look, Tricky Dick, check it out. 1977, all 4 gas giant planets are aligning. You can get all 4 of them within 12 years. That's within a few congressional terms or presidential terms. You know, whereas normally to get to Neptune, if you've studied home and transfer orbits, maybe you're learning that in space camp, it takes 30 years. We got there in 12 years. But this alignment, again, only every 176 years. So they told Nixon, this happens in 1977. And the last time this happened was 1801. And Jefferson blew it. Don't make the same mistake. And Nixon said, great, let's do 2. And that's what everybody... A Jefferson fan over here, or a young Jefferson fan. So those opened up the outer solar system for the first time, these beautiful JPL Voyager missions. And that's what inspired me to come to JPL. Little thinking then I would spend 7 years on Galileo, the first Jupiter orbiter. The next step after the flybys is go and orbit these gas giants and study them for years and all their dozens of moons, magnetic field rings. And then right after that, 20 years as the lead propulsion engineer on the Cassini mission to Saturn, the first Saturn orbiter. So as if my career couldn't come any more full circle, and I'll spoiler alert, Cassini is no more. We crashed into Saturn on purpose last September 15th. So this is kind of like my group hug therapy tour, 2018. I don't think I can hug this many people. We'll be here all night. But it's a victory lap / say our goodbyes to Cassini. But I had 20 years on that mission. So how do you follow that up? What do you do? I'm actually on Voyager now. Can you believe it? I start half-time in the fall. I'm 10% at the moment. I'm moving to half-time in the fall. The very mission that inspired me, 41 years after launch, still talking to both spacecraft. It has the gold phonograph record on board. Now, if you don't know what a record is, this side of the room, ask your parents. But in 1977, that was the way that you had your music. Vinyl, it's hip with the kids now, right? So everything's vinyl again. And it had the pictures, greetings, languages, sounds, music from planet Earth, because Carl Sagan, amongst others, figured out this had solar system escape velocity. It will forever encircle the center of the Milky Way every 225 million years, just like the sun does and the planets, but it'll never see the sun again. So it's kind of our calling card to the cosmos. What do you think they fought most about putting on the record? What do people have the most personal taste in? Music, exactly. I want more Beethoven. No, more Leonard Skinner. Darn it, come on, So they just fought over the music, and and there's pictures on board and greetings and all this. We generally didn't, like, should we show war and disease and famine? And no, it's kind of like a first date with the universe. Let's put our best foot forward, show them just the good stuff. So anyway, just what a thrill to be working on Voyager after all these years. But tonight is about Cassini, reliving 20 years of this glorious mission at Saturn. Here's some of our greatest hits as we went through the mission here. So that's a view of Saturn. Everybody like my 450 nanometer laser pointer? I love this thing. Straight from China, might even be legal, I'm not sure. So this is a view of Saturn that you do not get from the Earth. This is 900 million miles away from the Earth and the Sun because look at the shadow Saturn is casting on its own rings. That is a side view of Saturn, a geometry that is impossible for planet Earth. We also have the black and white cookie moon, Iapetus. One side's as white as snow, the other's as dark as charcoal. We're not sure why. Enceladus, this ice ball of a moon that should be boring, geologically dead, and yet it's active. It has water geysers that spew ice crystals into space. We'll talk more about that. The surface of Titan, I'll talk about that as well, and that's what it looks like. Voyager saw Titan, but as a orange hazy ball. Cassini brought along radar and cameras that can penetrate the clouds and see the surface for the first time. We also see beautiful detail in the rings. What an incredible journey this was. Next slide, please. Well, how do we name these spacecraft? Well, this is actually a two-part mission. It's called Cassini Huygens. If there's any Dutch in the audience, I apologize for my horrible pronunciation of Huygens, I think is about correct. But we had a European hitchhiker on our back here that rode for 7 years for free. And then we put the whole spacecraft on an impact trajectory with Saturn to release this Huygens probe so that it could go explore Titan up close and personal. And that was a little scary. Well, first off, we had to do that release on Christmas Eve because we are slaves to orbital mechanics at JPL. When Isaac Newton, when he says, how do I phrase this? When we have an activity, Isaac Newton calls the shots, right? And it's, okay, he says jump, we say how high? In what direction, and what holiday will you be ruining this year, right? So that was Christmas Eve of '04. Now, I was also scared because our beautiful orbiting mothership was on an impact trajectory with Titan, and that was not good. So luckily, we fired the engines afterwards and got it off of an impact trajectory as the Huygens probe came down. So two-part spacecraft. We have Huygens was a Dutch scientist. Now, he's the first. Galileo looked at Saturn in a ring through a telescope and saw a blob with a couple of side blobs, basically like love handles like me. So as the telescopes got better, Huygens figured out these are actually rings encircling Saturn. And so that's why we ended up, and this is pretty early. Telescope's only about 45, 50 years old at this point. Whereas then, so that's why, since he discovered the nature of the rings, and Titan, of course, too. That's why we named the Huygens probe that went to Titan after him. Now, Cassini is a Giovanni Domenico or Jean-Dominique Cassini, French-Italian astronomer, and he discovered 5 of Saturn's moons. He discovered the Cassini division, which is a gap in the rings right here. Now, we were going to take the spacecraft in that gap. Thank goodness we didn't. It turns out it's full of dust and it would have killed us, so we're really glad we didn't do that. But even in a modest telescope, if you look at Saturn, and it's up right now, you can see this thin pencil gap called the Cassini division. But more probably for our adults, has anyone heard the last name, the surname Cassini, other than the spacecraft, the Cassini division, or the astronomer? That's actually a famous last name from 20, 30 years ago in another context. Does anyone know? So there's a famous French designer named Oleg Cassini. So he's like the Versace of the French. Versace's Italian and Oleg Cassini is a French designer. And he was rather upset that this spacecraft was called Cassini. So his people called us up. How dare you use my name on your spacecraft? I sue your pants off. I sue you back to the Stone Age. Well, actually, get a hold of yourself. It's Jean-Dominique Cassini. It's not named after your little French designer. Oh, never mind then, But we were petrified around launch because for about 1 year there, we just knew we were going to get sued using the name Cassini. So all the t-shirts around that time have the beautiful picture of the spacecraft and no name of Cassini on it. And they're collector's items now, of course. But anyway, it was not that gentleman after all. Next slide, please. Okay, this is for our future engineers. This is not your father's Oldsmobile. This is a big spacecraft. It's about 23 feet tip to tip, weighs about 6 tons at launch. It's 22 feet high, 13 feet across, very heavy. No solar panels because it's too far away. The inverse square law, you only get 1% of the sunlight out at Saturn that you get at the Earth. So we have these nuclear batteries here called RTGs, radioisotope thermoelectric generators. We love those things. They have no moving parts, and if we could get them in your cell phone, because they last for decades and no moving parts. Now they're radioactive and they cost $50 million, but other than that, they're a really good power source. But look at the power, 700 watts, half of a hairdryer runs the entire Cassini spacecraft. That's crazy. And look at this, half a gig storage. Ooh, that's not bad for 1997 when we launched here. And there's the Huygens probe, 700 pounds. So this is quite a beautiful spacecraft, and what a joy to work on it for so many years. Now, next slide, please. I think we have the launch, so I'm going to show the trajectory, and then pretty soon we'll back out of this. So there's a still. We had a night launch on a Titan IV Centaur, October 15th, 1997. And in one of the strangest cosmic twists in planetary science, we used all our launch energy to slow down, just like the Parker Solar Probe just did, so that we would fall in towards the sun. So there's the sun, here's Venus's orbit around the sun, Earth is out here, here's Jupiter's orbit, Saturn's way out here. So again, at launch, we launched backwards. We slowed down, flew by Venus right here, stole some energy from Venus, put us on this red path, brought us by Venus again, the Venus 2 gravity assist. That put us on this blue path, came by the Earth again, got some energy from the Earth that flung us through the asteroid belt out to Jupiter, and then another 3.5 years out to Saturn. Total trip distance, 2.5 billion miles. Total time, 6.7 years. And the question the kids want to know, what's your gas mileage? Well, I'll tell you what, we went 2.7 billion miles here on a few 100 to 1,000 gallon miles of gas. Move over Prius. We're a darn good hybrid. Unless you count the launch vehicle, then it's absolutely lousy. It's worse than a Humvee. It's really, really bad mileage. We had quite the beautiful launch though. So and by the way, we had this V-veg trajectory, Venus, Earth, Jupiter, gravity assist. Now, if maybe our 8th graders haven't seen this yet, but the adults might have had physics class, and one of the big tenets of physics is conservation of energy. Doesn't this sound too good to be true? You fly by a planet, you get all this thousands of miles an hour added to your speed. Isn't energy conserved? If it is, what gives? Where's the energy coming from, or what's happening? And don't tell anyone, but we slow the planets down when we fly by them, including the Earth. We change the Earth's orbit a couple inches every few 100 million years. It's okay, no environmental impact statement this time. But Earth took one for the team, Venus twice, Jupiter once. It's quite the clever technique. So while we're pulling the video out, I got a little launch story. Now remember I talked about the nuclear material on board? So there were some people, Galileo had some of this plutonium as well. It's not a reactor, it's just the gentle decay of plutonium is used in a thermionic converter, which then runs electricity. And before we play this, I'll finish this tale, because before launch, we had our issues. Now, Galileo launched in October '89 on the shuttle Atlantis, and we had issues there. People came and sued us to block our launch because they said, if you have a launch accident, you're going to hurt all the nice people in Central Florida. Everybody at Disney World, breathing in plutonium dust. And I can't sit there and lie to you and say we won't have a launch accident. We know launch accidents can happen. We've seen it before, tragically. So what we had to do is show that the RTGs couldn't release plutonium even in the event of a launch accident. And that was fun, if you like destructive testing, and we do. So we blew them up and shot them with guns and set them on fire, and we could not get the plutonium out of the RTGs by design, out of the radioisotope thermoelectric generators. So we felt safe. People brought their families. They watched a beautiful launch on the shuttle for Galileo in 1989. That didn't stop. People took us to court. So luckily, the judge threw it out so we could make our small launch window about 4 to 5 weeks long to get out to Jupiter. Now, 8 years later, 1997, Cassini had 3 times as much plutonium, 100 times as many protesters at the Cape. I blame the internet. In the 90s, they were able to find each other online and coalesce and descend on the Cape to block our launch, or attempt to block our launch. So they sued us again. Luckily, we got that thrown out of court. But they were a little more pushy to try to block the launch, including they came to Cape Canaveral, climbed over the chain link fence, and went to chain themselves to the Cassini launch pad to block the launch. Now, no problem, because once you cross the chain link fence, right, you're trespassing on Cape Canaveral, federal government property. We can arrest you for trespassing, take you to jail, which we did. The problem was one of the protesters was the cutest thing you ever saw, a little 82-year-old grandmother. So she comes up to the fence and is getting ready to climb, and we're like, this is a press nightmare. We can't look good in this scenario no matter what happens. What do? Think out of the box. Somebody come up with something. I've got it. Someone had a flash of brilliance. They walk out to the fence with wire cutters. They cut a giant hole in the fence. She walks across. We throw handcuffs on Grandma, take her off to jail, and everyone was happy. Except Grandma, but... So Grandma ends up with a record, but then we showed her first view of Saturn in a telescope, and she became a big fan of Cassini as the mission unfolded. So one of the problems, again, of trying to get these launched. Speaking of launch, let's see if we can get her off the pad, and we'll see if we have audio. Titan IV Centaur. Beautiful night launch, October 15th, 1997. We took off into the, and then we were swallowed up by a cloud. And we thought, oh, the mission's over. It's gone. Look, it just looks like it's gone. But we would not be denied. We burst forth from the top of the cloud and headed off with our date with destiny, which in this case was Venus, right? And 6.7 long years until we're out at Saturn. Oh, that was an absolutely beautiful launch. Okay, next slide, please. So, I forgot what comes next. We have to get back into the slideshow. Venus story. So we went by Venus for the gravity assist. We have done some cool stuff at Mars and Venus, JPL, and the whole US. We've done Venus balloons, Venus flybys. We built a mission called Magellan out of spare parts. We went and stripped the high gain antenna off of the Voyager model in the Air and Space Museum at the Smithsonian in Washington, D.C., threw it on a spacecraft and made the Magellan spacecraft, which in the 1990s went to Venus and mapped Venus for the first time through its thick clouds, 900 Fahrenheit, hot enough to melt lead, poisonous choking carbon dioxide atmosphere, sulfuric acid rain that would eat your skin away. Really nasty place. Even worse than LA, it's just really bad. So now, and we've done balloons, flybys, the orbital, but we've never landed on Venus successfully. And the Russians beat us. In the 70s, they landed Venera. They survived the 900 Fahrenheit. They went down amongst the clouds. They stuck the landing. They popped their lens cap off their camera. They took 360-degree panoramic views, the only pictures from the surface of Venus. They beat us at our own game, planetary science. But they had one chance before the spacecraft melted within a few hours. The Holy Grail, what is Venus made of? So they scooped up some soil. They fed it into their spectrometers, their fancy cameras and chemical sensors. They sent the signal to Earth. They were really confused. They're like, what? Polyethylene? Venus is made of plastic. They scooped up their lens cap. So you got to feel bad for the Russians. So cautionary tale, number one, for our young students. Be careful, think about where your lens caps go and your deployables and things like that. Okay, let's jump to 2000. Now the scientists, we weren't going to let them turn the cameras on because we're flying by all these planets for a gravity assist. And the scientists pouted, said, we want to see what Jupiter looks like. No, sorry, it's a gravity assist. You're right, it's engineering. But you know what? We have to calibrate the cameras on a known target. And we're like, you're probably right. Oh, those sneaky scientists, they get us every time. But they were right. And we ended up with the best pictures of Jupiter at the time, even though Galileo was there 8 years in orbit. How embarrassing for Galileo that Cassini, we just did a flyby and we got better pictures. But that's because we had the brand new spanking new 1 megapixel camera. It's good stuff. And we got this gorgeous shot here of Jupiter with its great red spot, a giant hurricane 2 to 3 times the size of the Earth that's been raging for hundreds of years. And Io, the volcanic pizza moon, 100 times more volcanically active than the Earth, with its shadow cast on Jupiter's cloud tops. These gorgeous shots, and we're not even out at Saturn yet. So these made the journey a lot of fun along the way. Next slide, please. Okay, now as we're getting ready, 2 weeks out from approaching Saturn, we flew by a moon called Phoebe. Phoebe's an interloper. It formed in the outer solar system in the Kuiper belt, and then somehow migrated in and got captured in orbit around Saturn. And the way we know that is it orbits Saturn backwards. So, and this is the best picture we had from Voyager when it went near Phoebe. Let's see if Cassini improved the view. Next slide, please. Spectacular. So we're not even at Saturn yet. We're 2 weeks out. I remember this was my 20th high school reunion. Everyone was showing baby pictures. Some were showing grandbaby pictures, which is kind of scary. I was showing Phoebe pictures at the high school reunion. That is one weird moon. So there's dry ice, carbon dioxide ice up here, permanently shadowed craters, dark material. It turns out the dark material spalls off of this and coats Iapetus, which was a white icy moon, the black and white cookie moon. So it's an icy moon covered with dark stuff from Phoebe. That's bizarre. But the real scary moment for me was 2 weeks later, because I'm the head propulsion person. Next slide, please. SOI, Saturn Orbit Insertion. We're flying backwards here, left to right, slamming on the brakes. A 96-minute rocket burn. If it works, great. If not, it's Voyager 3, complete mission failure. And in fact, the Huygens probe would fail too. We would not get the Titan data. So I was so nervous. The signal to get from Earth to Saturn was 80 minutes. The burn was 96 minutes. So when we just saw the burn starting on the ground, it was already finishing out at Saturn, or maybe hadn't started, right? So I was very nervous. I also got the job on NASA TV to do live color commentary and make a 96-minute burn interesting and riveting to a crowd. And this is coming off the 7 minutes of terror, because I worked Spirit and Opportunity, the bouncy airbag Mars rover landings 6 months earlier. That's good TV. Bouncing airbag, 7 minutes of terror. How do you top that with a 96-minute rocket burn? Another cautionary tale for the students. It's amazing they let me near a live microphone for the orbit insertion because I had some issues back in the Mars days. And anyway, a quick aside. So Spirit was one of the Mars rovers, landed January 3rd, 2004, successfully, bouncy airbags, all that. And Opportunity was its twin, coming in 3 weeks later for a bouncy landing. Now, since Spirit worked, a couple of politicians decided to come to JPL for the landing of the second Mars rover 3 weeks later, because it would probably work, and then they could be on TV associated with the winning design, even though they didn't help us at all, you know, but that's how politicians work, you know, sometimes. So Al Gore showed up, former vice president, as did our California governor as of January 2004. Does anyone remember who that was? Schwarzenegger, that's exactly right. So Jay Leno's joke, he said all the robots came to JPL for the landing because those guys are kind of stiff and uncomfortable on camera. I like that joke, I thought it was very funny. But they warned us, no autographs, no photographs, leave these guys alone. They want in and out, be on camera, and then out the door. But I said, I can't do that. You know, I collect photos with celebrities. It's a very Kansas hayseed hobby, I grant you. Now, I knew I didn't try a picture. I'd get canned for that. But I met Al Gore briefly in our main museum, but the prize is the Terminator, Arnie, right? I want a picture with Schwarzenegger. What do I do? So we're in mission control, and there are long rows there. And he walks up and down each row really fast. It didn't stop for anything. And I said, there's my ticket. So I popped out of my chair, and I just decided to stand like this and block his path. And then he couldn't get by me, right? So he was very confused. He looked me up and down. He was like, congratulations to you and your team. You're doing marvelous work here at JPL. So, okay, the accent's not that good, but I was excited. You know, I met the Terminator. That was a cool day. So I'm just sitting there in mission control. I relived I recreated the moment. I did the accent. I shook all my friends' hands, coworkers' hands. And then the phone rings. Propulsion here. It's your mother. Hey, Mom, we landed. We made it, 2 for 2. we'll talk about that if you still have a job, pal. What do you still have a job? I just landed on Mars. I'm going to get a raise. What are you talking about? Still have a job. She said, well, I saw your little stunt, you know, blocking the governor's path, but then like imitating his accent, telling your friends. I said, you're 1,500 miles away. You're in Kansas. How did you hear this? She said, my dear, look to your right. CNN, there's a live mic right in your face. So that's my cautionary tale number 2 for the students. Watch those live mics. They're just deadly. They're really, really, just be careful. Promise me, don't let them take you down. Okay, next slide, please. What do we do once we're in orbit? Okay, so here's the Saturn system. We did a 4-year prime mission from 04 to 08. 75 orbits. We flew by Titan. Titan's bigger than the planet Mercury. So we can use Titan's gravity to sculpt and shape the orbit. And we had 5 co-equal science objectives. Titan itself, even though it's one of 60-some Saturn moons, it's that interesting because it's huge and covered in clouds. There's also Saturn itself, the atmosphere, the rings, which we know are 99% water ice and may have been a comet or asteroid pummeling into an icy moon that then formed, those fragments formed the rings. The satellites themselves get 20%, and then the magnetic field of Saturn as well. So I think if we can back out of the PowerPoint, we have what's called the petal plot. So this is an animation showing those first 75 orbits from our 4-year prime mission from 2004 to 2008. So here we go. First long looping orbit. Oh, all these elliptical orbits. It's Kepler on steroids. It's so beautiful. Now, some of them are in the ring plane of the planets. Some of them are looking at Saturn like a bullseye. So it's just, what a beautiful choreography, a cosmic ballet, if you will. So we have a whole navigation team that helps us figure out how to do this. Now, as a lead propulsion engineer, my job was to fire the rockets actually 3 times for every elliptical orbit there. So as you're approaching it, as you're cleaning up, and then also at apochrone, which is a fancy way of saying the high point of the orbit at Saturn. So that was a lot there. By the way, I was the human gas gauge for the Cassini spacecraft. Now, I say that because your gas gauge in your car is a fill sensor. It measures the height of a liquid in a tank in a 1G environment, right? Because your gas in your car on Earth settles in the bottom of the tank, thanks to Earth's gravity. That doesn't work in space. It floats around, it clings to the walls. We use surface tension and wicking to get the material to come out the bottom. What that means is there is no gas gauge. I'm the gas gauge on Cassini. And guess what? I have uncertainties. So at the end of orbit insertion, I'm an optimist, so I will say how full we are rather than how empty. At the end of orbit insertion, we were 1/3 full. After the 4-year prime mission, we were 10% full. We did a 2-year extended mission, full funding, during the Saturn Equinox, because we arrived in northern winter and we went through the spring. Spring was cool because the rings disappeared as seen from the sun and Earth. So we discovered new moons and saw long shadows on the rings and a bunch of detail. So we get to 2010, we have 5% of the propellant left. And we asked all the scientists, what do you want to do? And it's like herding children. They never want the same thing, right? There's 12 different science instruments. They all have different objectives. They all said the same thing. They said, we want to go another 7 years. We said, are you crazy on 5% of the propellant, 7 years? And why do you all agree? We're very suspicious. You never agree on anything. Well, because that's another Saturn season. So we arrived in winter, we've seen spring, we want to go to summer now. And then by a symmetry argument, going from winter to summer is like going from summer to winter. So as long as you can see it through half of the Saturn year, and the Saturn year is 29 years long, then we can see everything. And so that was my job then, is to make 5% of the propellant last the next 7 years. And so if you think you've been on the freeway, oh, am I going to make it to the gas station? Well, our nearest gas station was 900 million miles away, right? That was pretty scary. And at the very end of the Cassini mission, I can confidently say we ended up with 1% of the propellant left, plus or minus 2%. So that's rather scary. What that means is in the last 3 or 4 years of the mission, we could have run out at any time. Now, because of that, we took to a JPL tradition that I will now describe. I don't have a slide for this, but it has to be told. Back in the 1960s, JPL was riding the Apollo wave. We had a lot of funding, and before we commit Neil and Buzz down to the surface, what if they disappeared in hundreds of feet of dust? We want to make sure we want to send robots there to soft land on the moon without people. And we did that with the surveyors. 5 out of 7 were successful in the 60s. But before that, we had to prove we could just get to the moon with a mission called Ranger. So Ranger was a very simple spacecraft with a camera. You launch it, send it to the moon, take pictures as you're crashing into the moon, crash, and mission over. But you send the data back in real time. The first 6 Rangers all failed. That was a dark, dark time at JPL. So the first 2 had launch vehicle failure. And then the next one, launch vehicle worked, but the spacecraft failed. And then the next one, the launch vehicle worked and the spacecraft worked, but the camera failed. And then the last 2, the launch vehicle worked, and the spacecraft worked, and the camera worked, but we missed the moon. And that's kind of a big barn of a target to miss, only a quarter of a million miles away. So they came to JPL, said, NASA headquarters, said, "We love you, JPL, but we've lost all faith in you. Ranger 7 has to work or we're shutting you down. Have a nice day." No pressure, but so someone presumably had no fingernails left to chew in the Ranger 7 control room. So they brought in a jar of peanuts, and they're nervously eating the peanuts. They pass it down the row to their friends. And Ranger 7 worked. We crashed to the moon, we took pictures. So they brought the peanuts back for 8, 9, and 10. They all worked. One of the next missions, they forgot the peanuts. They spectacularly failed again. Okay, then we remembered, okay, this must be important, for about 2 years. So we had all these successes. And then towards the late 60s, I forgot which mission, we had a 40-day launch slip. It's biblical, 40 days, 40 nights slip. Why won't this launch? Bad weather, range, safety, technical. This mission is cursed. What have we forgot? I know. They brought in the peanuts, launched the next morning. So we are not superstitious at JPL. But every mission since 1965 has had the JPL Lucky Peanuts. It's in our script. It was 9:48 p.m. on Mars landing night. Thou shalt pass the Lucky Peanuts down the row. So now because of this, we usurped this tradition for Cassini. So for every main engine burn, we would do the Lucky Peanuts to make sure we weren't going to run out of propellant. No problem, because Lucky Peanuts work. The problem was the last big burn of the mission was March 25th. 2016, Good Friday, and I'm a practicing Catholic, and that's a fast day of obligation. Thou shalt fast. What am I, my mortal soul, Lucky Peanuts, the future of JPL. I was torn as a good Catholic boy here. What do I do? And I said, this new Pope Francis seems kind of chill. Maybe I can get a papal dispensation for Lucky Peanuts on Good Friday. Well, he's probably too busy for that. And then I said, if I tank this mission, it's not just me that loses the job. I take a whole team out. Pretty un-Christian-like, right? So I said, forgive me, Father, glug, 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 Lucky Peanuts. My mortal soul took one for the team. You're welcome, Cassini, but we did not run out of propellant March 25th, 2016. Next slide, please. Thank you, yes. Okay. Why study these moons? Why go back? Titan is incredible. It's bigger than Mercury. It's covered in these clouds. It has a thick nitrogen atmosphere, thicker than Earth's. But what we found out, it's the most Earth-like body in the solar system if you put Earth in a deep freeze and you changed out water for methane and ethane, natural gas. So everything you could think about on Earth due to having water as a solid liquid gas, we see on Titan 900 million miles away at 300 below zero with natural gas. So we have oceans, lakes, rivers, fog, mist, lightning, clouds, dew, erosion, rainbows. It's all there at 300 below with liquid natural gas. Isn't that crazy? So the young kids, I tell, if you were going motorboating there, bring your parka, it's 300 below, and then put some liquid oxygen in your gas tank and put a hose out in the lake and suck up the fuel. The lakes are made of fuel, right? So it's an amazing place, and we couldn't see it from Voyager. So we took care of that with Cassini. We have a radar that can penetrate. We have the Huygens probe that went on its one-way journey. Next slide, please. And this is a video. I probably would skip the video in favor of time. It just shows the Huygens probe being gently pushed off Christmas Eve of '04. And this is arguably the most amazing thing Europe's done in space science. They landed. We stuck the landing. Next slide, please. This one might actually autoplay. This is we had a camera on the Huygens probe. The first half of the movie really stinks because we were covered in clouds and we didn't see anything. But then finally we burst out of the clouds coming down and we started to see some really funky stuff on the surface of Titan there. Look at that. That is some weird looking stuff. And next slide, please. look at the still images. So the first thing the press said is, you faked the whole thing. This isn't Titan. This is Los Angeles. There's the Pacific Ocean, Malibu, LAX down here. You know, river channels totally dry, devoid because of the massive drought. It is LA, you know, it's just crazy. But those are dried methane and ethane, natural gas river channels that were, you know, coming down to a methane sea. Now, it turns out we landed down here in Vegas. They'll bet on anything. They bet on whether we'd land in a liquid or solid. Turns out it was 60-40 for solid versus liquid. We ended up landing in a solid, but it was kind of a mushy beach. We were actually warmer than the surroundings. So after we landed, we warmed up the surroundings and a poof of methane came off us. Who hasn't been guilty of that, right? So it happens, you know. Next slide, please. So what did the surface look like? We took a photo. We weren't necessarily going to survive the landing, and we only lasted a few hours on battery life. But as the mothership orbited overhead, we took this beautiful picture from the surface. Pretty orange there because of the haze in the atmosphere. But look at this beautiful vista. It's gorgeous. Now, when nature makes rocks from scratch, are they smooth or jagged? Jagged. Are these smooth or jagged? Smooth. Why? Erosion. They've tumbled down a liquid methane and ethane river to this side. I mean, that's amazing to me. And now I knew we made it. We were in the public consciousness because I was checking out of the supermarket 1 week later. And look what I saw. Next slide, please. So now I'm a kitty person. So you'd have to be a kitty person to love those kitties. They're pretty gnarly looking. But this dude actually gave me nightmares. He's scary, you know. Now, that was until I remembered these rocks are 1 inch across. So he's like a little pocket monster. Oh, it's pretty cute there. But that was quite the day there, mid-January 2005. Next slide, please. Okay, most Earth-like body in the solar system, craters, wind-driven patterns, wind dunes made of hydrocarbons, like almost a paraffin wax. Clouds, mountains, river channels, not a lot of craters because the atmosphere is thick and things tend to get burned up in the atmosphere. Crazy world. Is it our favorite moon of Saturn? I would never pick favorites. I love all my 60 children equally, but next slide, please. Look at, well, before we do that, let's talk about chemistry a little bit. This is the upper ionospheres. In other words, where you get charged particles in the upper part of an atmosphere. Venus has some oxygen, nitrogen, helium, all kinds of good stuff. Earth is basically oxygen, nitrogen all the time. Mars, very similar to Venus. Jupiter's basically just hydrogen, helium. But look at Titan. Look at that organic soup. There are more organic molecules here than in Walter White's chemistry lab, if you know what I'm saying. So, I mean, that is crazy. So the very stuff that makes us up may just line this Saturn's moon of Titan. It's really weird. Now, is there life there? It's pretty cold for life to get going, but boy, the raw ingredients seem to sure be there. Next slide, please. So then on to maybe what, if I had to pick a favorite, gun to my head, I might have to say Enceladus. Enceladus is this tiny ice ball that should be geologically dead, boring, unchanged in the 4.5 billion years since the solar system formed. It is not. It has these weird blue tiger stripes, a real lack of craters. So we flew by 100 kilometers away. Next slide, please. And we took its temperature. And here's what we saw. The South Pole was like 30 or 40 degrees hotter than the equator. And that's no less surprising than if you flew by Earth and the equator was 30 or 40 degrees hotter than the North and South Pole. That's really weird. Like that's where the sun shines, but it's much hotter at the pole. So we took a local temperature. Look, ooh, the tiger stripes are hotter than other things. What's going on there? And then the camera people said, can we take a picture of Titan in the dark? And we're like, all moons look the same in the dark. What are you wasting our time for? You're probably right. Just, trust us, Try it on a whim, see what happens. And of course, they knew what they were doing. Next slide, please. In the dark, we discovered Enceladus has active water geysers. The press dubbed them cold faithfuls. They spew ice crystals out into space and form Saturn's E-ring. So there's a movie of them coming out of the South Pole. The mystery is, why is this moon geologically active? It should be boring and dead. There's something underneath, melting water. So it actually has a subsurface global liquid water ocean with hydrothermal vents, the very place where life may have started on Earth. And that's why Cassini had to plunge into Saturn and take one for the team. It was a victim of its own scientific success. We couldn't risk Cassini with bacterial spores crashing into this glorious moon and contaminating it until we can get a future mission there. Our 8th graders figuring out how can we get out to that moon, melt a submarine through the ice and go exploring that subsurface Enceladus ocean. Rather tricky problem, by the way, but we need your help. Work hard in math, science. Maybe you can come help figure out how to do that. Adults too, we'll take your resumes as well. Next slide, please. Okay, the rings are gorgeous. We see all this, we thought they might be featureless blobs, and it turns out there's these spiral density waves, and then some galaxy experts saw the rings. And they're like, oh my gosh, you've proved our theories. Like, what are you talking about? You know, we're nowhere near the galaxy. We're still well within our solar system. They're like, you don't understand. These spiral density waves are the same things that happen when spiral galaxy arms form. You're actually studying it up close at Saturn in the rings. Who'd have thought that, right? We actually helped out our astrophysics cousins, you know, with their work with galaxies. I just love this stuff. It's just amazing what we get to do. Next slide, please. Okay, there's Iapetus, the black and white cookie moon. Next slide, please. So it has a belly band a little wider around the equator, again, just like me. So a propulsion person sees this, so that's a propellant tank. That's the weld, you know, around the tank. Some people see a walnut, you know. But now if we blew up Iapetus to the size of the Earth, this would be a pretty big mountain range. Next slide, please. So we'd be 20 times higher than Mount Everest and more than twice as long as the Andes. This is quite the impressive mountain range on the belly of Iapetus. Next slide, please. So there's the whole system, you know, all kinds of moons here, 60-some moons. Here's the rings and where the moons form. Enceladus makes Saturn's E-ring, as we talked about. The rings are named in order of discovery, A through G. Any musicians in the crowd? Of course, that's your scale, right? So composers have built symphonies on D, C, B, A, on the order of the rings from the planet, which is not in the order of discovery, because some are brighter than others. So that's kind of cool. It's really a beautiful place that begged exploration for you know, the 13 years we were there. Next slide, please. Oh, now Prometheus. Oh, I love this one. Let's find that movie, that Prometheus movie. So Prometheus is a shepherd moon of Saturn. There are these moons that orbit near the rings, and like they shepherd the particles and keep them there. But Prometheus is a little naughty. Now, in mythology, Prometheus, what did Prometheus do? Stole fire from the gods. Watch Prometheus. He's going to dip into Saturn's ring and steal some material. And he's going to wait to do it while Saturn's in the dark. Oh, you scamp. He thinks he got away with it, but no, look. We can see him stealing material. Let's watch him do it again. Caught red-handed. Prometheus dipping in the rings, leaving this gravitational wake when we're back in the sunlight. It's crazy. It's just a crazy system out there. Next slide, please. Okay. Now the north, that's right. And by the way, great audio visual. We had, and I take full responsibility, the videos weren't embedding properly and playing, so we actually have to pop out of the slideshow, go back to the videos. Now look at this, the North Pole. This was crazy. Voyager knew about it. Nature does not like sharp corners. I will remind the conspiracy theorists that those aren't sharp corners, they're rounded corners, but that it sure is a pretty perfect hexagon. We just wish it were a pentagon. We'd get military funding in perpetuity. It'd be awesome, but you know, nature tends to like the hexagon better, but we still don't know why it's there or how it formed. Big mystery. Next slide, please. Running out of time. Now Hyperion, the loofah sponge. That's a weird looking moon. So Saturn never failed to surprise us and send us back to the drawing board. Next slide, please. So there's some dark material. We'll just fly through these here. Got to get, now look at this moon, okay? Now this one made us be a little freaked out, and here's why. This is a picture from 1981 from Voyager 2, and that is the moon Mimas. But George Lucas made Star Wars in 1977. Do-do-do-do, something is up here. So we don't know what's going on there. The TIE fighters are not real. That is another acronym, by the way, twin ion engine. But that's quite a bizarre thing. Next slide, please. Okay, so how do we say goodbye to a mission this beautiful and amazing, right? What do you do? Well, we came up with a bold plan the last year of the mission. The first thing we would do are what's called the ring grazing orbits, the F-ring orbits. Look how close to the rings we're getting. So we go into this polar orbit, 20 orbits here, November of 2016 through April of 2017. Then we flew by Titan and did the unthinkable. Titan's gravity swung in one fell swoop. You have to do it in one orbit, right? Because we can't travel through the rings, we'd crash. We jumped the gap and then did 22 orbits, proximal orbits, between Saturn and the rings itself. Oh, that was exciting. From April through September last year. And next slide, please. Here's some of the stuff we saw in the last year of the mission. Scalloped edges, these beautiful moons inside. I'd play that lie. Tethys on the rings there. The hexagon is back. Beautiful shot of the rings here. Gorgeous. I mean, the ring detail was amazing. But the one that blew our mind and made us hungry was Pan. Look at that thing. What is that? Fried egg? Empanada? Ravioli? Gyoza? I'd eat that. It's 20 miles across, too. I think I could put a dent in it. But look at the ridge here. This weird, isn't it weird? This is the last year of the mission after 20 years, and we're still saying, why? What's going on? How did that form? Why does it have this is solid. There are craters in that lip. Now, it turns out we think we know what formed. This is the equator of that moon, and it gathered up ring material as it swept it clean. But it's still really weird and beautiful. The solar system, our imaginations were never as grand as the solar system turned out to be. Next slide, please. So here's our website, saturn.jpl.nasa.gov. And next slide, please. What I want to do now this one's going to make me cry. It's about a 3.5-minute video. But I want to talk about how we said goodbye for this mission.
A lone explorer on a mission to reveal the grandeur of Saturn, its rings and moons. After 20 years in space, NASA's Cassini spacecraft is running out of fuel. And so, to protect moons of Saturn that could have conditions suitable for life, a spectacular end has been planned for this long-lived traveler from Earth.
5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a 1 billion-mile trek to Saturn. We have cleared the tower. Program is in. Full program is in.
In 2004, following a 7-year journey through the solar system, Cassini arrived at Saturn.
To the SOI burn attitude or pointing position and light up the rockets.
The spacecraft carried a passenger, the European Huygens probe, the first human-made object to land on a world in the distant outer solar system.
Huygens arrival on Saturn's moon Titan.
For over a decade, Cassini has shared the wonders of Saturn and its family of icy moons, taking us to astounding worlds where methane rivers run to a methane sea, where jets of ice and gas are blasting material into space from a liquid water ocean that might harbor the ingredients for life. And Saturn, a giant world ruled by raging storms and delicate harmonies of gravity. Now, Cassini has one last daring assignment. Cassini's grand finale is a brand new adventure. 22 dives through the space between Saturn and its rings. As it repeatedly braves this unexplored region, Cassini seeks new insights about the origins of the rings and the nature of the planet's interior, closer to Saturn than ever before. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends as Cassini becomes part of the planet itself.
Okay, I can't end on something that sad. I just can't do it. You know, you've been such a lovely audience. How about we take a little victory lap and relive curiosities? Thank you for the support. That was a tough night. I'm not going to lie to you. After 20 years, we had to watch that beautiful spacecraft vaporize. But now, forever, it's part of Saturn. That last minute of data will be worth dozens of PhDs for the next 10, 20 years, perhaps to our space campers. I always say this, now it was grueling getting here, a 15-hour trip to Alabama from California, but if I keep one kid out of law school, it was worth it. So I can't end that sad. How about let's relive the magic of the night we last landed a rover on Mars, August 5th, 2012. Let's see if it works. So we're in our blue shirts. Look right up here. Look.
Coming up on entry.
Yes! 1 second in the video.
Vehicle reports entry interface. At this time, it will
Peanuts were there.
pressurizing the propulsion system
Times
to
Square,
increase the thrust
1:30 in the
of
morning,
system.
thousands
We'll
watching
use
on the
that for relative
Jumbotron.
maneuvering in the atmosphere. We're about to do. We are standing by. for
Yay,
guided
Marshall.
Start of guided entry. We are beginning.
NASA Jesus, we call him. Now that's NASA Elvis. He was very nervous. He was supposed to sit, but he was too nervous. He was pacing the whole time.
At this time, the vehicle is beginning to steer its way to the target. We have seen peak deceleration. It is starting its first bank reversal. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's.
Here's Mohawk guy. He got very famous after landing. I'll tell you about that in a minute.
We should have parachute
Head of
deploy around
JPL, head of NASA. No pressure, but real picture from one of our orbiters here. Look at that picture of the parachute during the 7 minutes of
We
terror.
are decelerating.
But somebody put it on Facebook, naughty, naughty, another cautionary tale for the students. Watch your social media
We're down to
presence.
90 meters per second at an altitude of
That was real video.
5 kilometers and descending.
Real video on the right, animation on the left.
Standing by for batch shell separation.
NASA Elvis pacing.
We are in powered flight. We're at an altitude of 1 kilometer descending.
This rover was too big and heavy for
Standing by for
airbags.
sky crane.
We had to come up with a crazy
crane
new
started.
landing, the sky crane.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars.
And Jesus wept. Times Square going nuts. Nice cameo upper right. Wow, this brings out the best of us. So many missed high fives. We really need to work on that as scientists and engineers. Maybe you can help the next generation. And after 5 minutes on our screens, the first pictures from this part of Mars. that was a good night. Okay, I'll close with this. Now, I was told I have an hour. I started, I think, at 37 after, so I'm going down to the minute now. I think I've got about 5 minutes for questions, maybe, with your blessing. But I'll close with this thought, especially for our young students. If these kind of questions interest you, here's the questions I get to help answer every day. And they're rhetorical, don't yell the answers out. But if you like these questions, maybe a job at NASA, at Marshall, one of the other NASA centers, at least in a STEM field, maybe that's your future. And here are the questions. How old is the universe? How did life start on Earth? Is there life in our solar system, single-celled life other than on Earth? Is there intelligent life outside the solar system? What's the fate of the universe? Why is it in 2018 we don't know what 95% of the universe is? That's pretty embarrassing. Are we messing up the planet so our kids and our grandkids can't live here comfortably and safely anymore? So if these questions interest you, NASA, a STEM career, could very well be in your future. Thank you so much for coming tonight. It was really a terrific honor for me to be there. Thank you. Oh. Thank you. Now, wouldn't you know it, I forgot one slide. And I can't not show this slide. I'm sorry I had to run late, but I have to show this slide. Look at this picture. It's actually a mosaic of about 200 images. Twice in the entire Cassini mission, as seen from the spacecraft, the sun was behind Saturn. Now, we can't point the cameras at the sun, it fries them. But in an eclipse, we can do it. So this Kodak moment came along, and we knew it'd be beautiful, but we never dreamt it would look like this. That's a real color picture of Saturn. And it's so spectacular and beautiful, I don't even know where to begin. So we've got the rings, the sun's poking out here. This is sunrise all at the same time over the whole part of Saturn. There's faint rings discovered with this images. There's the E ring, the G ring, it's all there. I'm not seeing it in this. I bet if we got the lights down, I might see it, but I'm not sure. But the best part of this shot is a tiny little single pixel. Any guesses what that is? And you can, Earth, that's us, that's all 7 billion of us on one pixel. Everybody that's ever lived, everybody you've ever known, everybody you've ever loved, all the kingdoms and the fighting for this little piece of one pixel. And every person on Cassini, when we saw that, we wanted to give a giant hug to our home planet. And we got along a little better with our enemies. We're such a small cosmic speck in the universe. Let's take care of this beautiful home planet and keep the exploration going. We stand on the shoulders of giants. I can't wait for the future. Thank you. Any questions? I'd be happy.
All right. Thank you very much. We have time for a few questions.
Didn't you record the sounds of Saturn?
We did. Now in space, of course, no one can hear you scream, as they say. So what we did is we converted the plasma waves and the radio waves into an audio frequency. And then and we've done the same at Jupiter and other places in the solar system. So it's a way, think of that, this is a way for our visually impaired students that we may want to inspire as well. It's a way for them to experience planetary exploration as well.
Will we ever colonize Titan?
You know, I think so. I think we'll probably start with Mars. It's a little closer and a little easier. You know, we want to, by the way, where we need help with the students, we've talked about, not rowboats, but boats, submarines, blimps that fly around Titan and do little touchdowns in the lakes. And so there's lots of really cool stuff we can do on Titan before we send humans there. But yeah, I think so. The beauty is that the hydrocarbons are there, right? So I think we will be burning fossil fuels on Titan because we have lakes of methane and ethane. So at least the fuel is there.
So a lot of the moons were very similar to our moon and the roundness of our planet and Saturn itself. But I saw that a couple of the moons weren't exactly round? Why is that?
That's great. I love this question. And I didn't know, I'm not a scientist, I play one on TV, but I've learned this from our scientists. So what happens is if a body gets big enough, it has so much self-gravity that it smooshes itself into the minimum volume for a given surface area, and that's a sphere. But if moons are smaller, they can't do that. So like in the asteroid belt, that's why we have all these irregular shaped rocks. And some of those moons that you saw, the Loofah Sponge and Phoebe and all that, they're small moons compared to the Titans and of course Pluto almost got saved as a planet, right? Because I know it's so sad, but now APL, Applied Physics Lab, that's one of JPL's friendly competitors, and they beat us for the right to a Pluto mission after we'd been to Mercury and Venus and all. That was their last planet. Ooh, that steamed us. They launched New Horizons. But en route, their target got downgraded from planet to ice dwarf. So have fun at your ice dwarf. JPL's been to all the planets. Now, I say that a little glibly, of course. Pluto ended up being amazingly fascinating. Discovered by a Kansas farm boy. He lived one county from where I saw the pictures in National Geographic. So I went to his farm and saw his childhood farm, read his biography. I said, this is not enough. I got to meet this guy that discovered Pluto. So I did a nerd pilgrimage, drove 1,000 miles from Pasadena to Las Cruces, New Mexico, where he retired. I sat in his living room in 1996. He was born in 1906, discovered Pluto in 1930, age 24. So he's 90 years old. I sat in his living room. I said, why'd you move to Arizona and discover Pluto? He said, I hated wheat farming. It drove my hay fever crazy. And I was cracking up. That's why my dad moved to Wichita, the big city in Kansas. And he passed away not 8 months later. So he didn't live to see Pluto demoted. His wife made it to 99, so she saw the spacecraft launch. But my favorite part, he was cremated, and they put 1 ounce of his ashes on board the spacecraft. So he got to fly by Pluto 3 summers ago. But the new definition of a planet, it has to be big enough to be spherical. Pluto still scores that. It has to orbit the sun rather than another planet, so it's 2 for 2, but it has not cleared its planetary neighborhood of its nearby neighbors, since it crosses an orbit of Neptune. And then you say, well, Neptune hasn't cleared Pluto out of the way, but Neptune's like this. Pluto's a little bug on its windshield. Forgive me, Pluto, but Pluto has a moon called Charon. They're in what's called synchronous rotation with each other, which I think is cool. Like our moon always shows us the same side. What's going on the back side of the moon? It doesn't want us to know. But we don't do that to the moon, right? We rotate every 24 hours. But at Pluto and Charon, they're both in 6.4-day orbits and rotation periods, so they always show the same face to each other. It's like two lovers. They're beautiful gays. They can't look away from each other. And then it would be 6 times bigger than our moon in their night sky, which is really cool too.
All right, here's our last question.
Hi, what exactly are the chemicals that make up the surface of Titan?
You know, it's mostly water ice, and then methane and ethane with the liquid, but those molecules I showed in the ionosphere, they actually rain out and form higher chain carbon molecules as well. So there's tholins and weird benzene type molecules, polyaromatic hydrocarbons they call them. The stuff that kind of forms the biology here. Now that's not saying there's life because it is 300 below. It's tough to get the biochemistry going when it's that cold. But it's an organic soup, if you will. And I love that the sand dunes are basically made of like a hydrocarbon, like a wax almost. It's a really crazy place. Solar system's a crazy place. So please come and explore it with us. You know, we're just thrilled that you're here, and thank you you were a fabulous audience, just really terrific.
Thank you very much.